You ready to go? Fantastic. So, good luck to the team. Vous pouvez commencer maintenant. Bonne chance.
Merci. On a toujours entendu qu'une image vaut 1000 mots et une vidéo, ça vaut des millions, combinant le mouvement, le son et l'émotion pour créer une histoire puissante. A digital twin takes
how
this
to
to a whole
combine
level.
sounds
It's
and
not just a
emotion.
video you can watch. It's one that you direct. You can pause, zoom in, simulate alternate endings, and rewrite the plot in real time. It's more than a 3D model. C'est une représentation vivante de notre infrastructure, alimentée par des données en temps réel, l'intelligence artificielle et la simulation.
Using
This is a new
real-time
way to
artificial
understand,
intelligence,
manage, and protect the critical assets that matter most to Canadians. L'infrastructure de transport du Canada comprend 2700 km de routes, plus de 700 ponts et tunnels.
Canada's infrastructure needs smarter tools.
En valeur économique pour les Canadiens chaque année. Pourtant, 40 à 50% des actifs
40 to 50% of this assets are not documented,
With rising traffic
and those who exist lack sophistication.
Our current approach for asset management isn't enough. The original Champlain Bridge is a cautionary tale. It had to be decommissioned after just 57 years, due in part to a lack of preventative maintenance. In its final decade alone, Canada spent nearly $400 million just to keep it operational, followed by another $400 million to dismantle it and $2.2 billion to build its replacement. This is why we need better tools, not just to react to problems, but to anticipate them, plan smarter, and protect taxpayer dollars. Nous avons besoin des outils comme les jumeaux numériques. Digital twins are real-time, interactive models that replicate the condition and behavior of physical assets. Integrated with Internet of Things, AI, and machine learning, they can simulate, predict, and optimize performance continuously. We're proposing a pilot with Samuel de Champlain Bridge, a uniquely equipped asset with over 400 sensors, tracking over 2,000 variables and 5 years of AI-ready data. With a design life of 125 years, it's essential that we manage it with tools that match that long-term vision. This pilot lays the groundwork for a proactive next-generation approach to infrastructure management. Aujourd'hui, la gestion des infrastructures repose
Today, the infrastructure management relies on manual and visual inspection and a limited use of data. This brings higher costs and defaults that are difficult to envisage and to forecast. This project envisages a new approach using the existing data and sensors in order to forecast risks and improve resilience towards climate change.
Champlain Bridge supports $20 billion in trade and 50 million vehicles per year. Keeping it safe and operational has clear national economic stakes. This pilot is built for public servants who manage infrastructure every day. Engineers, planners, asset managers. For them, a digital twin is a decision support tool that turns scattered data into actionable insight. They'll simulate future scenarios, assess intervention, and justify investment decisions with evidence, making decisions easier, faster, and more transparent, and ultimately delivering better outcomes for Canadians. Let's take a quick look into how our digital twin will revolutionize bridge health monitoring. I'll pass the mic over to my colleague to walk us through it.
With this twin, we'll be able to simulate stress scenarios, predict potential failures before they occur, and optimize operational strategies. As mentioned, Champlain Bridge is equipped with over 400 sensors, and these sensors monitor everything from displacement and corrosion to temperature and load mobility. When properly harnessed, this data becomes powerful assets for understanding and protecting this critical infrastructure. But the reality is, this data is highly heterogeneous, posing several challenges. And to manage this, we first route it through an IoT gateway, which ensures secure and efficient transmission to our platform. From there, the data enters a pre-processing pipeline where we clean and harmonize this data, removing noise, detecting outliers, synchronizing signals, and extracting features. Then comes the intelligence layer. Our AI engine uses descriptive models to monitor and understand behavior, predictive models to forecast risks, and prescriptive models to recommend actions. We also use generative AI models to simulate what-if scenarios to understand how the bridge might respond under different stress conditions. To ground these insights in physics, we combine AI with finite element models, creating the BRIM model, which is the core of our digital twin. All this feeds into a decision support platform where operators can assess risks, plan intervention, and keep our bridge reliable, efficient, and future ready. Now, let's see how this works using a concrete example. Strain gauge. This sensor embedded in the bridge measure how it deforms under load and send real-time data to the IoT gateway. The data is then pre-processed to analyze for key features like sudden spikes or gradual trends in strain. Next, our AI agent interpret this data. Descriptive models track trends, anomaly detection flags unusual strain near the joints. Predictive models forecast potential risks, and prescriptive models suggest actions like traffic rerouting or inspection. To validate this, the finite element model simulates how traffic and temperature affect strain in that area. And finally, everything is visualized in the BRIM, our dashboard for targeted intervention. To bring this vision to life, we have built clear implementation roadmap for research, from research to real-world testing. Phase 1 focuses on literature review, data exploration, and AI model prototyping, laying the foundation for predictive insights. In phase 2, we'll develop a sensor-based database, pre-processing pipelines, and AI engines for early anomaly detection using tools like Python, Kafka, and deep learning libraries like PyTorch and TensorFlow. Phase 3 is about the full system integration, developing the finite element models, combining them with AI components, creating the BRIM models, and conducting final testing, either physically or through simulation with platforms like ANSYS or Autodesk Rivet. This roadmap is already supported by a partnership that's in the development between HICC and NRC. At every stage, we are set up to iterate, validate, and deliver real measurable outcomes, ensuring high confidence in execution. This is a foundational framework designed for scale. What we are building can be adapted to other critical infrastructure, from bridges to buildings and transit systems to utilities. Digital twins are not needed everywhere, but for high value, high risk assets, they can be game changers. By starting with a flagship asset like Champlain Bridge, we demonstrate not only technical feasibility, but also strategic blueprint on how departments like HICC and PSPC can modernize asset management across the board, maximizing values, minimizing risk, and setting new national standards.
Les jumeaux numériques ne sont pas qu'une tendance. Ils représentent la nouvelle norme.
Digital twins are not just a trend, they're the new standard. The global market will be multiplied by 10 in the next 5 years, according to forecasts. While governments across the world are investing, and we don't want to be lagging behind, and we should act now.
Data and the AI expertise to act now. This pilot directly supports public service modernization by transforming how we anticipate, maintain, and invest in critical infrastructure. It is a first step towards smarter and more strategic asset management that delivers lasting value for Canadians. We're not just developing a tool, we're shaping and future-proofing the way our government manages infrastructure in the 21st century. Intelligent, proactive, and resilient. Thank you for listening, and we're happy to take questions.